today we're going to talk about 3 isometric transformations.
Isometric is what your book calls rigid transformations. You're going to mostly hear me use the term isometric, and we're going to talk about what that means in just a second. But there are 3 isometric transformations that we'll be working with this year. And the first is a translation. Okay, and translations are just simply movements, right? It can be horizontal, it can be vertical, it can be at diagonals. Second, we're going to look at reflections. Okay, and what makes reflections special is that they have a line of reflection. Okay, so oftentimes when we're using the coordinate plane, we use the x-axis, the y-axis, or sometimes the line y equals x as our line of reflection. In reality, we can use any y equals mx plus b. So any line that we can make on the coordinate plane can be our line of reflection. Thirdly, we're going to learn about rotations. Okay, and rotations don't have a line, they have a point that we call the center of rotation. Okay, I realize I'm giving you information without explaining what everything is, but we're going to cover all of this. Oftentimes the center of rotation is the origin. However, the center of rotation can be any point. It can be any point whatsoever on the coordinate plane. So let's talk again about what makes something an isometric or rigid transformation. Well, isometric transformations preserve the following. They preserve distance. Okay, so in this case, we're talking about distance between points, or sometimes we can just think of it as length, right? Okay, number 2, we preserve angle measures. We can think of these two. These two, I don't want to say they're the most important, but they're certainly the 2 that we will work with the most. And they have to do with congruency, right? For example, we can say that a figure is congruent to another figure if the lengths are the same measure and the angles have the same measures. Okay, so isometric transformations leads to congruent figures. Okay, but there are 3 more that I'm going to mention, but I'm not going to talk about them a lot. We'll come back to them. Okay, the first is collinearity. Next one is parallelism. I can't say it, but I can write it. Parallelism. And the last one, my favorite one, betweenness. Okay, and the easiest way to describe that is that the order of the points between other points will kind of stay the same. Isometric rigid transformations preserve distance, angle measures, collinearity, parallelism, and betweenness. So, get a nice clean sheet of paper. We're going to do our transformations on a coordinate plane so that we can do mathy with our graphy. So go ahead and give me a y-axis and an x-axis.
And we'll do a translation,
which is an isometric transformation. And let's take a triangle ABC. we're going to translate triangle ABC, 10 units to the left, and let's do 5 units down.
Let's see, here, here, and here. And we'll call this A, B, and C.
And let me give you those points over here. So A is going to be at 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. So at positive 6, positive 8, so you can plot that. B is going to be at 7, 8, 9, 10, 11, 12, at positive 12, 8. And C is going to be at 1, 2, 3, 4, 5, 6, 4, at positive 6, positive 4. Okay, so plot those 3 points right now, and I'll give you a second to do that.
And once you plot them, you can use your straight edge to construct the triangle. Right? Points A, B, and C are the vertices of our triangle. Right? Vertices is the plural of vertex.
Break the triangle up into its 3 vertices and move those 3 vertices separately. So that's what we're going to do. And before we do that, let me give a term. We've used this before, but we call, when we're doing a transformation, we call our original our pre-image. Okay, so you guys should know that. You should know that this is called the pre-image. And we're going to use prime notation for our image. So let's start with point A, which is right here. And let's move it 10 units to the left and 5 units down. So I'm just going to count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 1, 2, 3, 4, 5. And I'm going to put that point there, and I'm going to call it A prime. Okay, so I'm going to double check 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I went 10 units to the left, 5 units down, and I call that point A prime. Because A prime corresponds with point A, right? They match up, they go together. Okay, next I'm going to do the same thing with B. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, and 5. And that, I'm going to call that B prime. So B prime corresponds with point B. And in fact, line segment A prime, B prime corresponds with line segment AB, right? So of course, you know what comes next, C. We're going to find C prime. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 1, 2, 3, 4, 5. And that gives me C prime. All right, so once you've found A prime, B prime, and C prime, feel free to use your straight edge to construct the triangle A prime, B prime, C prime. We call this new triangle our image, right? In a sense, it's our copy. Notice this triangle is simply moved over here. Now, a couple of things. Because this is an isometric transformation, that means that we should have preserved distance. And we should preserve angle measure. And we're going to check that in just a second. So let's check that with our compass, right? So the first distance I'm going to measure is between points A and B. So my distance between point A and B I can see is 6 units, but I'm going to use my compass to set my radius to 6 units, and then I'm going to check A prime, B prime. And hopefully they are the same, right? We write that as AB equals A prime, B prime. Okay, likewise, I can check BC and compare that to B prime, C prime, right? BC, B prime, C prime should be equal. And I write that as BC equals B prime, C prime. And finally, I check the distance between A and C. And it should be the same as A prime, C prime. Okay, so I'm going to write that as, I'm going to actually write it as BC, wait, I did BC, CA equals C prime, A prime. Okay, so there are only 3 sides to a triangle, so it makes sense that there are 3 measurements that are equal. Okay, what about my angle measure? So I'm going to use my protractor to get an approximate angle measure. And starting with angle A is easy because we can see that on the coordinate plane that A is a right angle. Correct? So clearly, the measurement of angle A equals the measurement of angle A prime. Again, how do I know that? Because they both measure degrees. So that's a freebie. What angle B? Okay, so if I want to measure angle B, I'm going to put my protractor here. And notice that by using the grid, I can extend this side here, right? And I can come up with a measurement of just about 35 degrees, right? There's 10, 20, 35 degrees. So angle B is just about 35 degrees. And I can check angle B prime. And miracle of all miracles, I get just about 35 degrees again. Remember, that's not an exact measurement because I'm using my protractor, but I can assume that they're close enough that probably the measure of angle B is equal to the measure of angle B prime. Okay, and finally, let's do the same thing with angle C. So angle C appears to be, if I follow this up, it appears to be 60, wait, that's not right. Appears to be 55 degrees. That makes sense. Okay, and then I'm going to check C prime, and I get about 55 degrees again. So I'm going to go ahead and say I think the measurement of angle C equals the measurement of angle C prime. Now, remember that we said B was about 35 and C was about 55? What's special about that? What's 35 plus 55? That's 90 degrees. And of course, this is 90 degrees, so that gives me 180 degrees. Triangle sum theorem. All right? So, this is a translation. It presents distance, preserve angle measure. We say that triangle ABC is congruent. Okay, and this is where we use this little symbol here, congruent to triangle A prime, B prime, C prime. Okay, and congruent means same measures. Okay, and it really means all of this, right? So rather than writing all the sides are equal and the measure of all the angles are equal, we can just say that the 2 triangles are congruent, and it says all of that. Right? So this little symbol saves us a lot of writing. All right, let's do some mathy to prove, or to see if it matches up with our graphy. So when we're doing translations, the mathy is called mapping. Okay, so mapping is our mathy. And when we map, we take our points represented by XY, and we draw this little arrow, and we come up with a rule. Okay, the rule tells us what to do with our points. In this case, it's a fairly simple rule. For example, when we start at point A is 6A. Okay, how do we get to A prime? We move to the left 10, and then we go down 5. Well, on a coordinate plane, moving to the left is subtraction, right? So we're going to take our x minus 10 points, right? So this minus 10 means move to the left 10. For our y value, that's our vertical position. And so we're moving down 5. So we write that as y minus 5. Okay, take a second to think about what that means, and hopefully it makes intuitive sense. That if I'm moving to the left 10, I'm just subtracting 10 from my x value. And if I'm moving down 5, I'm subtracting 5 from my y value. Now we're going to use this rule to find our corresponding points. Okay? So let's say we didn't graph this at all. We could still use this map in order to find out where the transformation would take us. So I'm going to draw my little right arrow, and this time I'm going to put A prime. And I'm going to use my rule to find out what A prime is. Okay, so I'm going to take 6 and plug it in here for the x. What's 6 minus 10? Negative 4. Right? Good. Okay, and now for my y value, I'm going to plug the 8 into the y. 8 minus 5 is 3. Okay, so without graphing anything, I'm able to use the math to find my A prime value. Let's see if this matches up with our graph. So A prime should be at negative 4, 3. So if I start at the origin, 1, 2, 3, 4 to the left, 1, 2, 3 up, we can see that A prime is located at negative 4, 3. Okay. Let's do the same thing with B prime and C prime. So to find B prime, I'm going to plug x, 12, in for x. And 12 minus 10 gives me positive 2. And I'm going to plug 8 in for y. 8 minus 5 gives me 3. So my B prime should be located at 2, 3. And if I go to my graph and start at the origin, 1, 2, 1, 2, 3, I can see that B prime is located at positive 2, positive 3. Finally, let's do the same thing for C. C prime, plug in 6. 6 minus 10 is negative 4. Plug in 4. 4 minus 5 is negative 1. So C prime should be located at negative 4, negative 1. And we can see that 1, 2, 3, 4 to the left and 1 down. That is correct. All right. So the mathy for a transformation is what we call mapping. You should know that. You should know that in mapping, we always start with our xy and we apply a rule to it, right? In a sense, the rule is just plugging in our x and plugging in our y. And then from that, we get our corresponding points. And of course, if we connect those corresponding points, we get the image. We get the image. This would be our pre-image, right? These are the vertices of our pre-image. These are vertices of our image. So this is pre-image in our mathy way, and this is our image. Okay? When we see it on the coordinate plane, it looks like this. Let's go to a nice blank sheet of paper, and let's do one more transformation today. And what we're going to do is a reflection. We'll do a rotation later this week. So let's do reflection. Reflection over the y-axis, and the y-axis is actually where x equals 0, right? We say that's the line x equals 0, right? That's our line of reflection. All right, and the reflection is a rigid transformation, right? Or isometric transformation. Let's go ahead and make our xy axis. You can see that the line of reflection is going to be that y-axis. Okay, so I'm going to give you a whole bunch of points. Go ahead and graph those 6 points to make a hexagon. Six-sided figure is called a hexagon, and this is probably a hexagon that you recognize. Okay, so connect your points to make your hexagon. And if you did it correctly, it should look like mine. Kind of an L shape, right? Not usually what you think of when you think of a hexagon, but it is a hexagon. Okay, and this is pre-image. Pre meaning before we transform it. All right, so we're going to begin with the graphy part. What does a reflection mean? Well, there's a couple things I want to say about a reflection. When you think about when you look into a mirror and things are reflected back at you, they look a little different sometimes, right? So if you have the letter L on your sweatshirt and you look in the mirror, it looks backwards to you in the mirror, right? That's something we call the orientation. So the orientation changes in a reflection, and that's going to become important, and we'll talk more about that later. Another way to think about reflections is to think about the line of reflection, instead of being a mirror, to think about it as a fold. If I were to fold my paper at the line of reflection, in this case the y-axis, then the image caused by folding over would be the reflection. What happened? Where is my A prime? Where is my image from A as it relates to my line of reflection? Well, if we go from A, we can look at the perpendicular distance to the line of reflection. In this case, just going horizontally. I would count 1, 2, 3, 4, 5, 6, 7. 7 units to reach the mirror, or the line of reflection. And so the image will appear, if you get farther away from your mirror, it looks like you're farther inside the mirror, right? So if I'm 7 units away from my line of reflection, then the image is going to be 7 units on the other side. 1, 2, 3, 4, 5, 6, 7. And so that's where my A prime is going to be. Okay, so let's go ahead and do that with all of our points. So if I take B, B is also 7 units, and therefore I go over 7 units. Right? C is 5 units from the line of reflection, so I'm going to go 5 units on the right side. Okay, so go ahead. E is just 3 units, so I'm going to go 3 units. F is 3 units. D is 5 units. And I think that's all of my points, so let's label them. This would be F prime. This would be E prime. D prime. C prime, and B prime. Make sure you label these correctly because that will help you to see the orientation. Okay, then if I connect A prime to B prime, etc., we should see the shape emerge, our hexagon. This, of course, is our image. And the orientation changes. Okay? This is important. Only in a reflection does orientation change. All right, so we should remember that we preserve distance and we preserve angle measure. And this one's pretty easy to prove, right? Because we can see that AB is equal to A prime, B prime. Now we could just count, right? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay? And we can do the same thing with all of the points. BC equals B prime, C prime. CD equals C prime, D prime, etc. Right? So those would be really easy to check. Also, the angle measures. The measurement of angle A should equal the measurement of angle A prime. Well, A is what? A right angle. In fact, all of these angles are right angles, are they not? Therefore, you can clearly see so finally, let's look at the mathy behind the graphy. So we have, when we're mapping a reflection, we're going to start with our X and our Y, and we need a rule. So what happens with our rule? We can check it quickly. We can say that A is at -7, 4. Okay, this A is going to be at +7, 4. And so we can see that the vertical value of each of these is going to remain the same, but the horizontal value, the x value, is going to be the opposite, right? If it's negative, it's going to become positive. So we indicate that by putting the negative sign in front of the x, but we read that as opposite x. Okay? Notice our y value doesn't change at all, so we're just going to leave that as y. Okay, using the rule, we can find that a prime is opposite of negative 7 is positive 7, and the y we leave unchanged. For b prime, opposite of negative 7 is 7, y remains unchanged. And we can continue to do the same for each of these points. And if I didn't have the graphy, if I only had the map, I could then plot these points right here and get my image from my pre-image without having to do any counting whatsoever. Okay, so I hope that was helpful. The most important thing for tomorrow is that you know the 3 isometric transformations: translation, reflection, rotation. You know that reflections have a line of reflection, rotations have a center of rotation. Know these 5 things that we preserve in an isometric rotation. Okay, and although you should be able to graph, I'm not going to have you do any graphing on the quiz, but we will do some more graphing tomorrow. Make sure you have your compass, protractor, eraser, and pencil. And we'll have a lot of fun tomorrow. And we'll have a lot of fun tomorrow. And we'll have a lot of fun tomorrow.
And we'll have a lot of fun tomorrow.